I'm Alex. I'm one of the co-founders and CEO here at Snorkel. I'm also in faculty at the University of Washington in the computer science department. And today we're privileged to get to speak with Steve. Steve, you want to give a quick intro?
Yeah, thanks so much for having me, Alex. My name's Steve Bach. I'm a Snorkel researcher, and I'm also an assistant professor of computer science at Brown University.
Awesome. Today we're talking about a pretty big paper in terms of waves that have been made in terms of usage in the open source and number of authors. So this was the multitask prompted training enables zero-shot task generalization. This was at iClear this year. And it was a collaboration amongst a ton of different organizations. And Steve, you are one of the lead researchers. So you want to kick it off just by sharing a little bit about the paper, the model, and the overall kind of community effort here?
Yeah, absolutely. So this paper was a great community effort among many collaborators in the Big Science Workshop, and particularly shouting out Victor San, Albert Webson, Colin Raffel, and Sasha Rush, who are the other lead contributors to this work. And the goal of this paper and this entire project was to investigate how to improve prompting. So prompts are natural language representations of queries. They can look a lot like questions you might ask a human annotator, like, what is the topic of the following article? And prompting has gotten really popular in the last couple of years, particularly with the rise of large foundation models like GPT-3. And so we wanted to look at the question, how could we improve this method of prompting for tasks that haven't been seen before? In other words, for tasks that we don't have any training data for, that's sometimes called zero-shot learning or zero-shot inference. And how could we improve this process, particularly for models that are smaller than, say, the scale of GPT-3? Could we improve this process for, say, models that could fit on a single node?
That's awesome. And one of the things I guess that I think is really okay, obviously because of the data-centric bias of both of our work, right? This idea that you were able to get a model that was 16 times smaller than GPT-3, I believe, or
That's
something
right.
like that outperformed on a bunch of benchmark tasks by curating a training data set. Multitask training data set is, I'm being overly reductive, but just at a high level, it's a pretty interesting and relevant idea as we see so many more of these foundation model innovations come from something around data curation or development. One kind of follow on to this work that I'm curious about is what you think this translates to in practice. And so I think that all of the kind of base foundation models are going to incorporate some supervised, or I guess maybe one way we see it go is, there was your work, that Flan, I don't know when that came out, I think a little bit after.
Right around the same time, concurrent work.
Right around the same time. Yeah. So also incorporated some kind of supervised multitask pre-training. One option is, or one route is maybe this is just every foundation model that comes out, open source, closed source, includes not just self-supervised training, but also multitask supervised training. Another version is everyone starts doing their own multitask supervision specific to their data set, their organization, their types of tasks, and curating these big databases like you all did of multitask supervision becomes kind of part of the edge that people have in building their own foundation models. Where do you see this kind of playing out from this work that you did?
Yeah, I think that's a great summary. And absolutely, the big idea of this approach was, in my opinion, very data-centric, because prior to this work, the goal was just make the language models bigger, do self-supervised learning on more and more data. And so this work, you mentioned the concurrent work of Flan, and many works that have then come since have really followed this direction of saying, okay, to get best performance, to really adapt these whether they're language models or vision language models, whatever kind of foundation model we're talking about, in order to better align them with what people want them to do, we want to further train them on data that looks more like the tasks that we want them to eventually perform on. And so I think the trajectory is going to be increasingly specialized. And it's interesting to see how there are almost like family trees of models.
Yeah.
So we have like T5, for example, which T0 was descended from because T5 was trained in a self-supervised way. Then we fine-tuned it on what we call P3, this big collection of prompts. And now people are further fine-tuning T0 on using other types of techniques, incorporating things like co-training, semi-supervised learning, additional curated data. So all of these things are get added on to the foundation, if you will. And I think that is going to be increasingly important. That's certainly something that, like in our research, we're looking at is how do I get that additional knowledge, domain expertise, whatever it is, into that foundation so that when I prompt my model to solve new tasks, it can better answer those queries.
Yeah, that's fascinating, man. I know we're about out of time, or about to be out of time soon, but just that idea that, yeah, that family tree idea that you have this kind of hierarchy of specialization. You start with the self-supervised base, then you have self-supervision on subdomain legal documents. PubMed GPT just came out from CRFM at Stanford, and then you have supervised, like multitask supervised descendants, like in your paper. And it's a maybe daunting, but also fascinating and exciting front, because think of how many combinations there are of potential multitask data sets to train your model on. Right? It's not just look, we just train on this dump of data and it works. It's now you have all the combinatorial blow up of different kind of, training tasks that you could put together to then further train it. So it opens up this whole space of how to craft these foundation models. Maybe one quick tack on is, what was your experience of working in this very kind of open source community centric way versus a very kind of solo team closed source kind of project?
Yeah, I think it was a lot of fun. I haven't worked on a project with quite that many different collaborators, but I think it really complemented what we were trying to do in terms of collecting a diverse set of training data so that the model would better respond to a wide range of test queries. So we had lots of people from universities and other institutions all around the world contributing their ways of phrasing tasks to the training data. So not only was it a lot of fun and it was really cool to meet all of these new people, but I think it actually also really made the work a lot better.
That's awesome. I guess we have to wrap here. Unfortunately, I could go on and on about this work, which I think is just objectively so exciting. But again, really exciting themes around how obviously compute scale up and data scale up and architecture innovation is always going to be a critical piece, but how important the data set curation is, both the unsupervised data, but in the case of your work, the multitask supervised data set curation specific to the kinds of domains and tasks you're looking at. And that obviously a great data centric punctuation on the current state of foundation model. So Steve, thank you so much for taking the time. Also, for those that are watching, if you're interested in learning more about foundation models and large language models and all of a whole bunch of different takes on them, but especially the kind of data centric ones, please join us for a free summit on Jan 17. Just search for Foundation Model Virtual Summit, Snorkel AI, or visit snorkel.ai, and you can find a link there. So Steve, thank you so much. Great chatting as always.
Thanks, Alex.